Good morning, students. On your request and demand, today I am preparing your industrial automation lab practicals. So, in this session, what you will learn? You will learn how to make your practical file with all experiments. You understand the software RSLogix 500 and your Allen Bradley PLC, which you have in your lab, how to use it with the program, how to download the program, how to interface input and output and check. So before going to all the experiments and all, we will go through from your syllabus. Your syllabus is like that. The objective of the syllabus is to introduce basics of industrial automation, PLC and SCADA, then ladder programming, then describe interfacing of analog and digital devices with PLC. What is the objective? Objective of your this IA labs are first introduce the basic terms of PLC, SCADA. Then what are the outcomes? Outcomes are understand fundamental of PLC, develop ladder program using PLC instructions, and develop ladder program using advanced PLC instructions. So it is my request to you, each and everyone will go through your syllabus and you must know what is there inside this course. Now these are the 9 practicals. One by one, I will go through it, and every one of you should know what are the practicals, because you may do all or not do all, but it is expected from you that you know the names of all the practicals. So your first practical is the introduction of ladder programming, develop and simulate logic gates. When you can do this? When you know about your software, how in a your lab PC this software runs. If you don't know, you have never touched the PC, you never open the software, you never use the software, you are not able to do this. Then the second is the when you know the logic gates, then with the logic gates we have a Boolean equations. You have to make a Boolean equations, and then again you have to do the programming in the RSLogix software of Allen Bradley, and you download the program to the hardware PLC and you check on the simulator of your lab. Now third one is the simple on-off application. Means what? It is a motor, is a red switch, there is a green switch. When you are pushing red, your motor start, and still when it's a start condition, you touch your green, nothing will happen. But when you touch the red button, your motor will stop. So here you will learn the concept of the latching or interlocks. Then your next fourth practical is the to know about the timer operation in PLC. What is the mean of timer? Then you have to learn the application of the timer. And the sixth experiment is a just like a timer. You must know what is the counter operation of the PLC. Okay, and then seventh is the you know the application of the counter. Eighth one is develop and simulate ladder program for comparison operations of PLC, lesser than, greater than, like that. And then you have a two more as per syllabus. Any one you have to choose, but what we will do? We will do both for your better understanding, because PLC is a very important part right now in the industries. It is the now heart of the industry. Every industry works on the PLC, and in the industry we expect everyone know about the HMI, PLC and the SCADA, whatever the civil engineer, whatever is the instrumentation or any other discipline engineer. So these two are the DOL. DOL is the direct online. You know star delta also in electrical engineering. This is very simple start motor starter. And then PLC arithmetic instructions. You all know what is the meaning of arithmetic instructions. It is a plus, minus, division, multiplication and all. Okay. Now before going to these experiments, we must know how to make the ladder diagram and how it looks like. So if you see here, what is the meaning of ladder diagram? Okay, which IEC it's governed? This is 61131 standards, right? And then what is the ladder diagram? It is a graphical representation in a form of the ladder. We write the program. For that, you have to have knowledge of NO and NC, these two kinds of your operators. So NO and NC. This is the NO. If you want to understand what is the meaning of NC, this is the NC. And we see this is the coil. So in a coming slides, we will see more about this. Now you see here, ladder diagrams means it's a ladder. You see, you are seeing here, it is the kind of a ladder. In a ladder, what are different things is with NO, NC switches, NO switches. Then this is your output in the form of coil. This is the rung. This is the rail. Here you can understand in a better manner. So this is the relay logic. We have to convert. Our job is in a PLC to convert these relay logic to the your PLC logics. So this is the relay logic. This is the your gate, and this is your PLC. This is your RLC. Earlier those RLC circuits are used, and now with the PLC, the knowledge of the gate, we are converting it to the PLC or PLC logics. Now in the next slide, these doubts will be more clear. See, this is a kind of a ladder. You are seeing the ladder over here. Okay, this is a ladder. This is called the rungs. This is called the rails. This is the coil output, and these are the switches. Now we will understand in your lab how you will open RSLogix. You go to the PC, get the power to PC, let boot the PC, and then you will see this kind of screen in the PC like this. Okay. Now what we are learning? We are learning how to use RSLogix 500, because in all your practical you have to prepare ladder diagram first. So you will see this kind of symbol and you press it. This is for the RSLogix. When you press it, what will happen? You will see the screen like this. It will take some time because these are the heavy softwares. It takes time to boot, right? This kind of screen will come. So step 2. Then you have to press the file. When you press the file, your step 3 will come. It will come new. Now you have to press the new. When you press the new, another screen will pop up. In this screen, what is the meaning of this screen? This screen is saying, this is your software. What kind of hardware you are going to connect? Or with this software, what model PLC of Allen Bradley you want to connect? So in your lab, see, this is the important thing you can note also, because external examiners or in the interviews and all, people may ask, if you study the PLC, what is the model of PLC, what is the make of PLC, what software you used, right? So in your lab, the PLC hardware is a RSLogix 1400 series A. When you select this and you put OK as a step 4, then you will see this kind of screen. In this screen, you have to understand what is what, right? So for your understanding, I am giving this at 0000. It's the rung number. It's a rung, okay? And this is the rung end, the last line of your program. You will see what is the meaning, because there may be many rungs in a programs, right? Then this is the output data file. This is the input data file, binary data file, and the counter data file and timer data file. You can see here, na? Output, input, timer, counter. I'm not explaining others because it's not in the syllabus right now. But if you have interest, you can contact me or any other your faculty from this lab. They will explain you. So this screen here you can also see here. Okay, this is the rung. Okay, this is the branch. This is the NO. This is the NC. This is the coil. Now, after the screen and understanding the different meaning of different things, we have to go to the step 6. If I want to make a program, the first we have to highlight this. For doing this, we have to click here as a step 6. When you click, it becomes 0. Okay, hello. Now it says 0. Have you observed or sleeping? Earlier it is a screen I am showing what is what in this software, and when you want to go actually doing the letter diagram, making the letter programming, you have to click it. When you click, it becomes red. Means now you can do anything on it. For doing this, there are two ways. One is this arrow you can pick and drop here, pick and drop here. Coil also pick and drop here. And then you go to the addressing, output addressing and input addressing, because this is software. How hardware will understand where you are going to connect the A and B, your input and outputs. Then after this, what you have to do? You have to take out an example. I have given one ANO, took ANO, an example we have took the one NC and the coil. Then we will do the addressing from here. So how we will do addressing? Here, input addressing, output addressing, counter addressing, timer addressing at one slide I have shown you. It will not come in a one slide. First, you have to take the input addressing. You have to click here. This screen will come out. Then you select first I0.0. You have to select, and then I0.1 at which terminal you want it, input or output. You have to select. Similar way for the counter and the timer. You don't worry, when we will go in the details of the timer, counter and this, we will show you, and in the lab also we will show you on the PLC desktop. Now addressing, how we do the addressing? Addressing, file type, input, output, timer, counter, right? Slot number 0, 1, 2, 3, then word number and the last terminal number I:0.0/0. When you see the actual hardware, you will get to know about this thing. Now, what are the things used in a programming? I explained in the previous slide. Again, I am telling you, this is first is the your NO context, how it looks like. It's NC context, the green, because if you think the voltage is there, voltage is not going there because a current is not going there. Why? Because this is open. Here it is a closed. Then it is the coil. Addressing you can also see here. Then timer. In a PLC, timer is from 0 to 256, 255 actually. If you count it from 0, total is 256. It is 0 to 255. And there are three kinds of timers: on delay, off delay, and retentive timer on delay. All if then your experiment for the timer operation and the application of the timer, you have to do all these three relays, three timers. Then you have to explain what is the meaning of on delay, what is the meaning of off delay, what is the meaning of retentive delay, retent time delay, and then you have to make these symbols of that. You understand what is the enable, what is the DIN bit, right? Or what is the TT bits. These all you have to explain on your copy, and then you have to make the ladder diagram of it. This is the one practical experiment, and second is the you have used this timer in some application, maybe a traffic light. Traffic light, red is for 30 seconds, then green is again for yellow is again for 10 seconds, and again green is for the 30 seconds. This kind of program you can make. In the timer, the bit we told you, enable bit, TT bit, and the DIN bit. So you can study yourself also, and you can understand from here also how it is, and we will explain you when we will discuss about the application of this. Similar with the counter, you can use the up counter, down counter, what is the symbol of this, and how the contact of that counter is used for the further PLC program. It is given the addressing over there. With the application, we will use it. Like application means when a conveyor belt, and in conveyor some metal is moving, and you are counting how many metals they gone, 1, 2, 3, 4, 10. Then conveyor belt stop like that. So now first experiment is the introduction of a ladder programming, develop and simulate logic gates. Here first thing is you know about the logic gates. You all know how many logic gates you have studied. Hello, How many logic gates you studied? Yes, 7 numbers. What is the name of 7? Have you remember or not? If not, then you study and you know, because anyone can ask you about the gates. Now I will tell you how gates looks, what is the truth table, and how in a ladder diagram you will have this in a RSLogix 500 software. Okay, till now hope you understand. Now it is your first practical, you understand it. So in understanding this, first you know what are the name of different gates. Okay, all 7. I will not read for you, you have to read for yourself. Now this is the AND gate. In your experiment manual or the file, you have to write the name of gate, you have to draw the figure, to draw the boolean expression of this, y is equal to a dot b or q is equal to a dot b. Then you have to write the truth table. And now RSLogix software you have to open, you have to click on the rug, it will become the red. Then you double click, or by dragging you will take your a and the b and you have your output. Then in a software you have to check in the emulator also, when this is like right now the 0 0 and it is also 0, but when you put 1 then it will go to the here for the 1. If both are 1 it will 1, otherwise any one of 0 it will the 0. So you seen here the symbol, name, symbol, boolean expressions, and this the program. After that you download the program and you yourself check in your simulator how it's happening. When A is 1, B is 1, only then your output will come, it is 1, the light will glow. Similar way, AND gate. AND gate, or so in the OR gate symbol, it's a boolean expression, it's a program. Here what you do, in the program you have to first put this NO, then you have to add the one loop, and after that you again have a one NO, and then you have to give the addressing here and the output addressing, and you have to check this. Okay. And NOT gate, same way, NOT gate symbol, boolean expression, and your PLC program, and you check on the PLC. NAND gate, similar way, boolean expression, diagram, truth table, name, and the your PLC program. Then 5th, 6th, okay. Then I think you are able to see it, okay, right? And 7th. So these all about your first experiment. You have to write the name of the experiment, and you have to write theory of these gates, symbol of these gates, boolean expression of these gates. Then you will know how in RSLogix you will make this kind of ladder diagram. After making ladder diagram, you have to check the program is right or wrong. Then you run it, download it to PLC and the hardware simulator. By pushing this button A and B, you will check what kind of output you are getting, and you have to have a photographs of these and you have to put in your file. This is all about your experiment number 1. In the next video onward, I will tell you about experiment number 2, 3, 4, 5, 6, 7, 8, 9 and 10. Thank you very much. Thank you.